So we're talking about a completely revolutionary photonic integration platform. There's some really exciting science that we're going to do of the most exciting areas of modern physics, metamaterials that offer unprecedented optical properties, nanoplasmonics allowing us to control light on the sub-wavelength scale, and hybrid integration that allows us to control light in 3 dimensions. And it's these new scientific programs that will underpin this revolutionary photonic integration platform. CUDOS has a really world-class reputation and brand, and in fact we retain the CUDOS name in the new centre because of the very strong brand recognition it has. Researchers from all the world are attracted to work in CUDOS because it's a national centre, a collaboration that brings over 125 researchers together with international links with the world's leading research groups and partnerships with local industry.
Being associated with CUDOS is important because we have many different type of groups and expertise. Having a bigger team allows you to solve problems which you can't solve in smaller groups. Of course, success comes as a result of great achievements CUDOS demonstrated in terms of interactions between people, publicity, quality of research results, publications, and many achievements.
I think CUDOS gave us the opportunity to do really fundamental photonic science, and through CUDOS initiative, we can actually work on the very fundamental issues.
I think there's a lot of technologies that people take for granted in society today. All those ones and zeros that their computers spit out at them are actually carried by little light pulses, and that those light pulses go under the sea in optical fibres around the world. And I want them to understand just how that can happen at the speed of light, and that the bandwidth that they get is because of the bandwidth of optical fibres.
It's not just about speed, it's about bandwidth, it's about transmitting more information over fibre and building networks that can transport more information over fibre.
The capacity of an optical fibre is somewhat close to 30 terabits per second. Most commercial systems don't reach that capacity. It's all a matter of squeezing more data into the available spectrum. That's what we're doing with optical communications. We're squeezing more colours side by side in the optical spectrum, each colour carrying as much data as we possibly can.
With the growth in demand in applications from mobile and data and internet, that's pushing the limits of current networks. New ideas, new technologies need to be developed that can enable higher bandwidth communications.
Nanoplasmonics allow us the opportunity to make things, I suppose, greener and more efficient. And the reason for that is because you're taking, I suppose, light and you're concentrating it down to a very, very small nanoscale. This allows us to increase the interaction with material and therefore reduce the energy overheads.
People don't realise that the internet in fact consumes vast amounts of energy.
The most energy consuming part is the video transmissions. And as you see the YouTube or some other IPTV or video on demand services, the more TVs watched through internet rather than the broadcast media.
There's currently a revolution going on in silicon electronics. The limitation of silicon chips presently is the communications that occurs between chips and within chips is mitigated using electronics. And this is actually very energy inefficient and can create a lot of heat, which limits the speed of these chips. The revolution is the incorporation of photonic technology for this communication, but there's only so much that silicon can do on its own. So in CUDOS, we're looking at hybrid integration technologies to bring new materials to the silicon platform and other platforms to enable high-speed photonic signal processing and to overcome this energy bottleneck that's currently being seen in silicon electronics.
So currently we use electronics to do computing, but quantum photonics promises to provide much faster speed. So if we want to build a quantum computer, so we definitely need to make everything small so that we can integrate everything on a chip.
And these are technologies that promise to deliver us secure communication systems, incredibly powerful information processing systems for particular tasks.
In current telecommunication system, so it's very easy for the hackers, right, to get information or to steal information from you. But the quantum communication, quantum cryptography promises to provide an absolute secure way to secure your information.
The mid-infrared relates to a part of the spectrum which exists between 3 microns and 20 microns. What we're doing is we're trying to get the mid-infrared spectrum onto a chip. Essentially what we're doing is we're creating light sources in the mid-infrared, and we're creating optical circuits that can propagate light in the mid-infrared, and also detectors that can detect that light in the mid-infrared, and we're going to scale that down right down into small proportions, and that's the integrated optics component of what we're doing. This is actually a departure from the telecommunications part of CUDOS, taking all that wonderful technology development that we created in the first CUDOS, and we're transferring that up to the new CUDOS to start looking at integrated optics in the mid-infrared band. So it's quite a significant change.
But central to the new Centre of Excellence is in fact the science of metamaterials. This is one of the most exciting areas of modern physics. It's an area of science that has only been explored over the last 5 years. It's an area where Nobel Prizes might be won, even potentially in Australia.
Metamaterials can really bend light in a very efficient way. So imagine you have a pebble in water, and the water can go around this pebble. The same thing can be done with metamaterials, and the way to excite people is to tell them that this is a way to make invisibility cloaks, and students are really excited by this idea, and in this way we invite lots of school students to visit our laboratories to see how it is done, and we hope that in a few years' time these students will come as researchers in our labs.
CUDOS is very keen to reach out to secondary students. We want the students who are going to be the engineers and physicists of the future to know about photonics at an early stage.
I've actually been on the judging committee for the best student poster and so on, so I've been paying close attention. And I think the most important thing is that the students really take ownership of the project that they're working on. It's clear they're not just following the supervisor's instruction, but they're actually, they feel as if they're a member of the team, and they're actually partly responsible for directing the way the research is going, and they understand that they're responsible for how things are going to turn out, and they're enthusiastic to do the best they can with it.
I think it's important for CUDOS to reach out to industry. We have some really good partnerships with some companies locally. It would be really good for more of the companies in Australia who are interested in this kind of communications and signal processing expertise to become a part of CUDOS.
Finis is definitely interested in collaborating further. It's not up to us to come up with a multitude of brand new ideas which could be used in pieces of research here and there. We need to make sure that the product just does what we promise it will do. But that's why we're interested in seeing that happen.
The technologies are built on devices that are made in Australia, made from components that were invented and developed by people who worked with CUDOS.
No one else is doing this in Australia. It's good work of an international calibre. And if this can lead to a Southern Hemisphere manufacturing industry, that would be excellent. No reason you can't make these things in Australia.
We're really proud of the relationships we have with industry partners in Australia, and we're thrilled that we have an opportunity to work with multinational companies that are working at the absolute leading edge optical technologies, and through partnerships with CUDOS, we hope to grow their business and to develop new technology that will benefit Australia.